Hi everyone, this is Pramit SJ of Electrical Department and I would like to explain about Bicmos fabrication process. As the name itself suggests that CMOS, the complementary metal oxide, and bi, which means bipolar, which means it contains both NMOS as well as PMOS. Now let us look into the fabrication process. Now, if you see the structure of a bi-CMOS, it has one NMOS and one PMOS and one NPN BJT, that is a bipolar junction transistor. As we know, the NMOS fabrication, it will be easy to understand the bi-CMOS fabrication. Now, the following is step-by-step fabrication process. Now, the fabrication process, we require a silicon substrate to which we add a p-type impurity to form a p-type substrate, and on the p-type substrate, it is covered with an oxide to stop further oxidation. Now, window is opened in the oxide layer using UV rays. In the window, the n-type impurities are heavily doped and we make an n-type buried layer to accommodate the BJT transistor. On the top of the p-type substrate, we should form an entire surface of p-type layer to protect the buried layer. The same way as n-type fabrication, we will place a mold and by removing certain areas by etching process to form the windows on the surface, which is used to form transistors. From the two windows, n-type of impurities are diffused to form n-wells. One n-well is used for PMOS, and other n-well is used as a collector for BJT. The one more window is for NMOS. In this, three active devices, NMOS, PMOS and BJT are formed. Now, we are placing the polysilicon layer and again in the same process of UV rays, and we are removing the unwanted material. Finally, on the gate of the NMOS and PMOS, we have polysilicon. As we know, character is already formed and we are forming a base by inducing a p-type substrate into the n-well. Now, we should diffuse the n-type material to form a NMOS transistor and emitter base in character to form a BJT and to form a PMOS transistor. And again, a layer of oxide should be formed and UV rays process to remove the unwanted material. And the deposition of the material finally forming an NMOS, PMOS and BJT transistor. And thus, we create a bi-CMOS. Bicmos technology. Characteristics of bipolar technology: high switching speed, higher current drive per unit area, generally better noise performance, high power dissipation, lower power impedance and low packing density. The amplified Bicmos inverter diagram. The operation of bi-CMOS. The conventional Bicmos inverter. Combined advantage of bi-CMOS technology: improved speed over purely CMOS technology, lower power dissipation with purely bipolar technology, packing and board requirements, flexibility, input and outputs. Conclusion: development of VLSI Bicmos results in very high performance memories, gate arrays and microprocessors.